Welcome back to BugNoJutsu. In today's video, we are going to solve a very interesting and simple yet tricky problem from LeetCode: convert integer to the sum of two no-zero integers. Even though this is marked as an easy problem, it teaches us how to carefully handle constraints and edge cases, which are very common in coding interviews. So let's break this down step by step. The problem statement is straightforward. You are given a positive integer n, and you need to split this integer into two parts a and b such that both a and b are positive integers. Neither a nor b should contain the digit 0 anywhere in their decimal representation. And finally, when you add a and b, their sum should equal n. The question also guarantees that such a pair will always exist. If there are multiple valid answers, we can return any one of them. At first glance, this might look very simple because you might think of splitting n as 1 and n1. But the twist here is that we must ensure both numbers don't contain the digit 0. That's what makes the problem a little tricky. Let's take one of the examples to understand this better. Suppose n equals 11. If we directly split it into 1 and 10, the sum is correct, but 10 contains a 0, which is not allowed. So this is an invalid pair. Instead, we can take 2 and 9. Both numbers don't have any zeros in them, and they sum up to 11. Perfect. Similarly, another valid solution would be 8 and 3. So, multiple answers are possible, and any of them is acceptable. This tells us that the main challenge is not just about summing up to n, but making sure neither of the numbers has a 0. Now let's talk about how we can solve this problem step by step. My approach is very straightforward. We start by checking all possible numbers I starting from 1 up to n1. For each number I, we calculate the other number as ni. This guarantees that together they always add up to n. Now comes the key check. For each pair, we look at both numbers and verify that they do not contain the digit 0. This can be done easily by converting them to strings and checking if 0 appears. If both numbers pass this condition, we have found our valid answer and can return them immediately. This method works efficiently because we don't need to do anything fancy. The problem already guarantees at least one solution, so our simple search will always succeed. Now let's analyze the complexity. Time complexity: in the worst case, we may have to check all numbers from 1 to n1, so the time complexity is O(n). However, in practice, we usually find the answer pretty quickly, so it often runs much faster. Space complexity: we are only storing a few variables and converting numbers into strings for checking zeros. So the extra space usage is O(1), which means constant space. The key insight here is that the problem looks like a simple sum, but the digit 0 restriction makes it unique. Problems like this teach us to pay close attention to the constraints, because that's where the real challenge lies. Another point is that sometimes brute force is perfectly fine, especially when the input size is not too large. Instead of overcomplicating, a simple direct approach can solve the problem cleanly and efficiently. This problem is also a good reminder that string manipulation can be very handy even when we are solving numerical problems. Converting a number to a string just to check for the digit 0 is a neat little trick. And that's it for today's problem. We learned how to break down a number into two no-zero integers in a very simple way. Remember, coding is not always about writing the most complex algorithms. Sometimes clarity and simplicity win the day. If you enjoyed this explanation and found it helpful, don't forget to like this video, subscribe to BugNoJutsu, and hit the bell icon so you won't miss future problem breakdowns and tutorials. Drop a comment below with your thoughts or if you'd like me to cover a particular LeetCode problem next. Thanks for watching, and I'll see you in the next one.